All right, we got question number 35 here, which is your only 6-pointer, so you should expect to be spending like 10 minutes on this if everything goes perfectly. Coordinate proof is the type that I hope you do get. We got a bunch of slope formulas, distance formulas, and some explanations. But let's take a look at what's going on with this one. The coordinates of the vertices of triangle ABC are A at -2, 4. I'm going to graph that. B at -7, -1. 1, 2, 3, 4, 5, 6, 7, -1. And C at -3, -3. And that is our triangle. And the first part of this problem is to prove that this thing is isosceles. Got to know that isosceles means two congruent sides. And then you got to know that to prove that things are congruent, it is either going to be the Pythagorean theorem or it's going to be the distance formula. I'm going to use the distance formula this time just because, I don't know, I feel like it. X2 minus x1 squared plus y2 minus y1 squared. And now I'm going to do it for each of the sides. So let's switch over to blue. And I am going to do the distance from A to B, because I can just tell by looking at it that BC is the side that's not going to be congruent. So I know that these are the two sides I'm going to have to do. So distance from A to B means that I'm going to do x2 minus x1, which is -7 minus -2 squared plus y2 minus y1, -1 minus 4 squared. Just working through this. -7 minus -2 is -7 plus 2, which is -5 squared, plus -1 minus 4, also -5 squared. Negative times a negative is a positive, so we get 25 plus 25. And we get that the length of AB is the square root of 50. Don't really need to simplify this one because the goal is just to show that they are the same as each other, so I'm just going to leave it like that. I am going to shrink this thing down because I'm sure that I am going to run out of space if I don't make these things smaller. I think you actually have 2 full pages to do these problems on the Regents, so y'all have plenty of room. Just want to try and capture it all here. So let's go back, get a new color, and now I'm going to find the distance from A to C, because that's the other one that I can tell is congruent. Distance from A to C is x2 minus x1, -3 minus -2, should have that in parentheses, squared, plus y2 minus y1, -3 minus 4 squared. Something weird is happening here, and I'm glad it is. Let me see what goes on. Talk through why I think something weird is happening. Because I'm getting -3. Maybe it's not weird. I thought I was getting -3 minus -2, doing bad mental math and thinking that it was 5. And if I was going to get a 5 here and a 7 here, that was not going to give me the same answer. But -3 minus -2 is -1. And -3 minus 4 is -7. And now I think this is actually going to work out because -1 squared is +1. And -7 squared is +49. And I knew I was going for the exact same length. And so the fact that this thing worked out means I don't think I'm making a mistake. Things are going wonderfully. 5 minutes into this problem. Let me shrink this down just to save room. And now I can actually prove that it's isosceles. So I can say because the length of AB is equal to, don't have the symbol, but I'll put it in a second, square root of 50, and the length of AC is equal to the square root of 50. AB is congruent to AC. Therefore, triangle ABC is isosceles because it has two congruent sides. Got a bunch of little weird typos and symbols that I'm going to improve on here as I just move this around. So as I was typing this, I noticed that I wrote AB here. That is a lie. That is actually AC. So AC is the square root of 50, and all these things should be congruent. Actually, that's not true. AB is equal to the square root of 50. AC is equal to the square root of 50. And AB is congruent to AC. Therefore, triangle ABC is isosceles. So that's part one. That's probably 3 out of 6 points for this problem. And now moving on to the next part. Let's get a new color and move on to the next section. It says, state the coordinates of A prime, B prime, C prime, the image of triangle ABC after translation 5 units to the right and 5 units down. So since it says state the coordinates, I'm just going to get ready to write them. A prime, B prime, and C prime. And the translation, I'm just going to count it. 1, 2, 3, 4, 5 to the right and 5 down. 1, 2, 3, 4, 5. So that's going to be my A prime, which is at 3, -1. B prime, 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 down. That's my B prime, which is -2, -6. And I'm going to check all these to make sure that I'm right. And C prime, 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 down. That's my C prime. Didn't say that we had to graph it, but it seems like a good idea to me. C prime is 2, -8. So the way that I said I'm going to check this is translations, you could just add and subtract. So since this is 5 to the right, that means add 5 to the x values. -2 plus 5 is 3. -7 plus 5 is -2. -3 plus 5 is 2. I'm good with that. And 5 units down means subtract 5 from the y values. 4 minus 5 is -1. -1 minus 5 is -6. -3 minus 5 is -8. Solid on that. I am probably up to 4 out of 6 points on this. And final section, let's jump to a purple color. Prove that quadrilateral A prime, C prime, C is a rhombus. That is a little weird. Let me look at that on the graph. But the rhombus, I know I'm going to have to show that it has 4 congruent sides. So I am still in this distance formula area. A prime, C prime, C. So that is the shape that we have to prove is a rhombus. Oh, these problems are so long, but for 6 points, just going to keep powering through. I now have to do the distance formula only 3 more times because we already have the length of AC, so that's one of the sides, but then we're going to have to do it for all the others. So the distance from A to A prime is square root of, and I'm using these 2 points, x2 minus x1, 3 minus -2 squared plus -1 minus 4 squared. And I already know I'm supposed to be getting the square root of 50. We're looking for 4 congruent sides. I've got the first one. So 3 minus negative 2 is 5 squared. Plus negative 1 minus 4 is negative 5 squared. Feeling pretty good because I'm getting the square root of 25 plus 25. And I got that the distance from A to A prime is equal to the square root of 50. Said this is going to be at least 10 minutes. I don't know if it's all this formatting stuff or it's hard to write on the screen, but I am already at 10 minutes and got more work to do. On to the next one. I'm going to stay with this purple color, but now I'm going to do A prime, C prime. So the distance from A prime to C prime, just distance formula over and over and over. We are going to get 2 minus negative 2 squared. Already getting a little nervous about that number, but let's see how it goes. Negative 8 minus negative 6 squared. 2 minus negative 2 is 4. Something weird is happening. I think I see what's happening. 2 minus negative 2 is 4 squared plus negative 6. Negative 8 minus negative 6 is really plus 6, which is negative 2 squared. And I'm glad I made a mistake because this just happens all the time. I'm getting 16 plus 4, and I'm getting the square root of 20. And that's not the same. And I know it has to be the same because it's a rhombus. So I think I realized what I was doing wrong. I think I was using B prime and C prime. So I was just using these 2 points in the distance formula. So I was actually finding the length that I didn't care about over here. That one is different from all the others, which is why these problems end up taking like 20 minutes sometimes. So wonderful. Get to redo all this work over here because I chose the wrong points. I'm actually doing from A prime to C prime. Let's see if that one works out. So we're doing the square root of x values first, 2 minus 3 squared plus negative 8 minus negative 1 squared. Please give me the square root of 50. 2 minus 3 is negative 1 squared. Negative 8 minus negative 1 is negative 8 plus 1, which is negative 7 squared. Things are now going well because I got the square root of 1 plus 49, which is the square root of 50, which is what I know I needed. So the distance from A prime to C prime is that. I'm going to shrink this one down and hopefully not make a mistake on the last one. And what is the last one? So let me do a little bit of organizing. Boy, this is getting messy on the screen. Shrink this thing down. Always a good idea to keep your diagram labeled. So let's see. I already got A prime, C prime is congruent. I got A prime is congruent. I got AC from the beginning. So the last one that I need is the distance from C to C prime. C to C prime. Let's actually circle those so that I don't use the wrong points. C to C prime. So we got 2 minus negative 3 squared plus negative 8 minus negative 3 squared, which gives us what look like good numbers, 5 squared plus negative 5 squared, which is the square root of 25 plus 25, which is what we were hoping for, the square root of 50, and that's the distance from C to C prime. Shrink this thing down and write my concluding statement, because now I have all of the evidence to justify that this thing is a rhombus. I'm going to have to write small, make this smaller before I start. So always starting by talking about your calculations, because the lengths of A prime, A prime, C prime, C prime, and AC are all square root of 50. I'll put the square root in a second. That means all these sides are congruent. Therefore, quadrilateral A prime, C is a rhombus. Because all four sides are congruent. Those are long problems, but everything came together in the end. Just have to write my square root of 50 because I couldn't type it. Length of all four sides are the same value. That means they're congruent. Therefore, it's a rhombus because all four sides are congruent. All right, a little over 15 minutes. You should expect that final problem to take you that long, whether it's one of these or whether it is a statements and reasons proof. But everything seems to have worked out.